Wait for it. All right.
Okay. Kurt Lichtenwald, Gloucester High School, physics class. Teacher ID number 47123. So we're going to briefly do a class discussion, real quick review of what we've done over the last, say, month, right? And what we're going to start off with is series circuits. Okay, we did the series circuit. We learned how to draw schematics. We learned how to measure with a multimeter. We learned to set up a rest and virtual piece chart, measure, and then calculate for the other measurements. And then put it into an energy formula, convert it to kWh, kilowatt hours, and then figure out the cost of running this circuit for an extended period of time. Okay? Now that was easy. Series circuitry and all the rules that go with it. Then we came up to parallel circuit. And, you know, Kirchhoff's laws, loop laws, where we have to add the currents up in each loop. And this would be more representative of houses, how each house in the United States is set up. And again, you learn to measure the circuit, put a rest and virtual piece chart, and again, solve for the cost. So you now know why mom and dad get mad when you leave the lights on and the TV on when you're not at home. We took it to the next level, which most schools do not get to. In fact, honors doesn't even touch this. Doesn't do series, doesn't do parallel in our school. You guys take it to a whole nother level. You're going to see this at the college level. I just think it's important to actually stress this because most things are complex. They're not series or parallel. Most things are a complex circuit. So in this situation, you had to calculate the series parallel circuit, design a rest and virtual piece chart, measure, and to make it a little less confusing, we use sub-schematics, which break the complex circuit down into individual, simpler sub-schematics. Okay? And again, still same routine, figuring out how much energy you're using and the cost for actually using it for an extended period of time. Perfect. So where are we going with this? We know that we have an arts festival coming up, and the whole thing is to impress the local community with STEAM, science, technology, engineering, arts, and mathematics projects. And so we came up with this little project here. You're supposed to do a complex circuit. It's broad, so you can work as a group or individually. So today, I'd like to walk around the room, take a look at the progress that you've made thus far, and give you some suggestions. I want you to have your rubric out so that when I walk by, we can actually have a discussion on where you think you're going, especially material-wise. I picked up your project yesterday. It weighed like 60 pounds. Okay? It is. So we have time still to make adjustments. So if you could quietly, and no, I know it's going to be weird. Normally this room is chaos. Okay? We got music playing in the background. We got people just working on projects. Noise level's high. But for today in the videotaping, it's going to shift gears and it's just going to be like silence. It's going to be weird. Okay? And tomorrow we'll go back to our normal, usual Santa's workshop and have some fun. Okay? So go ahead and find your projects. I'll be by it in a minute. No stopping, right? Mm-hmm. You guys ready? So, looks, you got a power supply, right? What you got the voltage set to? 9.7. 9.7? And you got an on-off switch here?
Connect to a separate power source.
Ah, you have a separate power source? Okay. So this one controls... Go ahead, turn it off. Okay, turn it. So when that gets to the top, it's supposed to click. Okay, so That's going to rise all the way to the top. So when it gets there, it'll shut the motor off. Okay, so we still need to work on that a little bit, right? And the light system, it looks pretty good. You put what, 2 motors on there? Yep. Okay, let's shut that off for a second. You got it? Well, that's not bad. I think your batteries are starting to die here, so we need because these motors are drawing a heck of a lot of current. Yep. So go ahead and switch that up and mount these 3 extra lights. I take it you're using these lights as resistors to slow down the motor? Yep. Sweet. Very complicated, I'll give you that. So how is your schematic? That's going to be fun. You got your measurements?
Yeah, mostly.
Okay, so you still need to do this, that, those 3, yeah? If you actually do the voltage across the motor, right, and then the voltage, going in, and we just subtract that, the motor voltage, then you'll know what the resistors are. Does that make sense? Because they're in series. Yep. And just take that number, divide by 3, now you know each individual one. Okay? It's cheating, but it works.
Yep.
Okay. What do you got, schematic-wise?
Schematic-wise?
Yep.
One right there.
Well, that's just simple.
There was another one.
Okay, so we got to work on our organizational skills a little bit, yes? So why don't you work on that. Now, why artistically, now here's a good question. This is supposed to represent America, yeah?
Yep.
And the Twin Towers, is that what it is?
Yep.
And so this is a photo shot from up above?
Yep.
So we need to work on some painting that up a little bit better, yeah?
Yep.
And I like the but what's the beer and the Copenhagen aspect here?
Represents the continuous use of American-made products after a national catastrophe with the Twin Towers.
It's an interesting concept. I take it you got the beer cans and the stuff from your father? Yes?
Yeah.
Right,
Yeah.
there you go.
Recycling bin.
All right, so let's tweak that and start working on our schematics, shall we?
Yep.
You ready for me?
Yeah.
Let's take a look. Slide that way.
So we have the lights, which is controlled by this bottom switch, and then parallel, and then series. And then we have the 2 motors underneath.
So you made this boat yourself?
Yeah.
Out of foam?
Yeah.
Me and my brother made it.
And these 2 motors are controlled by these switches.
Very cool.
And
So that those are bilge pumps that you cut
Yeah.
the tops off, right?
yeah.
So they're waterproof. And I take it the 2 things right back here are for weight.
A little bit of weight and also hold it together. And all of our wiring is underneath here.
Can we open it and take a look?
It's a little messy, but we have our 2
Oh, you did a much
batteries.
better job with the shrink tubing. The shrink tape. That was good. Heat shrink. Excuse me. You still need to fix that one, okay?
Yeah, that one. And we just need to get the lights fastened down. And
I would highly suggest that you put something right here, so when somebody pulls on this, or when it's going, it's pulling, it doesn't rip the electronics right out. Does that make sense? That and monkey dung, yeah, the duck seal on there, so we waterproof it. I would get rid of this. You're talking 12 volts, right? Those motors are going to pull some amperage. Probably metal in your hands, probably not the best idea. Okay, so if you would just come see me, I'll get you a project box. Oh, you put that's smart. Yeah, you put tape in there to actually act as an insulator. Okay, so we definitely need to work on your soldering skills. Yeah.
yeah.
Okay. If it's ugly, we shouldn't use it. That's my #1 motto. Okay, so we want to make it look pretty as possible. But you got your schematic drawings. You got your rest of the virtual sheet chart. Okay, looks good. I'll look at it more clearly down the road. Yeah, but it looks good. Okay, these are double pole, double throw switches. Yeah. And I'll show you how to do that tomorrow
Alright.
on the schematic, yeah?
That's
Because these change direction. What? You guys ready for me? Okay. You guys ready for me?
Yep. So we have complex coming off of this battery.
Yeah, I'm digging the artistic flair.
You like that?
I
Thank
do.
you.
All right, so you got a motor attached to a fan. All right, go ahead.
Lights up.
And you got light. Well, the prerequisite was light, sound, and motion, right?
Yep.
I like it. You got the sound.
Yes. Got the motion.
It actually sounds like a propeller in the water.
Yeah. Good.
And you got the lights. Okay, so I'm not a big fan of the wires being exposed, right?
Yeah.
So we got to work on that.
Okay.
Put a little heat shrink on it, and we just heat it up and
Okay.
seal it. Okay. So you're happy? Oh, nice schematic. So you've got a series parallel circuit. So an REQ1 is all of those resistors equivalent. Boom, parallel. Eh, looks nice. Did you do your measurements yet? Oh, yes, you did.
And the time and the money are on the back.
Very good, very good. 1.8 kilograms per kilo. Yay! Looks great. I'm very happy. I personally would have taken this and put it in the ceiling and then attached this, and then you'd basically have a hanging ceiling
Yeah, we tried
fan.
to attach this to the boat. It wasn't working for us. So we just kind of tried to put it in the back.
Now we have time to make this even better.
Yeah.
So now you guys are really close to being finished. I want to see a pop. Yeah? So let's think about, in court you got all this stuff, artistic stuff. Now in electronics over here, the artistic stuff's kind of separate. Why don't we bring the lights or something in here? Like when we get an octopus toy, stick it here, and then stick a light bulb inside of it so it glows. Something along those lines, to make it a little more artistic. Yeah, and it should be minor tweaks to this. All right, but yeah, it looks really good. Very impressed. Let's see what we got. Hang on. Let me take a look at it. Don't drive it yet. Okay. I was skeptical when you guys started this. I really was.
I was too. I'm surprised it came together.
You've got. Let's see. You stole some of my metal that you didn't ask.
No, we had.
That's something that I wasn't really paying attention. I like the idea. Whose bright idea was that?
It's kind of a combination of all of us.
That was brilliant. Sticking the Christmas tree lights through the holes that already existed. I probably would have done it on both sides. Yeah. Maybe that's something we look at next couple days. Yeah. So you got.
Have enough power to light up all the lights.
I can give him more power. Maybe I got more of these over in that. Right in that drawer over there. Yeah. Okay. There's 9 volt and 12 volt ones. Piece of cake. So you made a remote control car with the Christmas tree lights attached. Nice LED setup. I probably would have put a load resistor in there. Yeah?
Yeah.
Are you coming right off the board with the voltage?
Yeah.
Yeah. We might want to tweak that. So tomorrow, let's talk about this, because if you leave this on for extended period of time, I'm worried that you're gonna fry something.
Okay.
Okay. But you normally don't put an LED straight off the battery because it's not a resistor. It's a one-way valve. So it's going through. It's basically creating a short circuit. So we put a load resistor in series with that, just so that it slows the current down.
Okay.
Yeah. But let's see it in action. So you.
Have 2 independent motors that are controlled by each one of the switches.
I see that. Yeah.
Right.
Let me just hold it like that.
Left one controls the left, right one controls the right. Button on the top makes start and go. Forward, backwards.
Now, I see your zip tie. I think we need to work on that a little bit.
Yeah, we definitely need a better way to mount the motors on because it's making the wheels go
all over the
line
place.
And everything.
Yeah. Might want to come during one of my robotics classes, and those guys can actually probably hook you up with some kind of strapping or use some of the Vex metal that we have over in the corner, which is underneath the glass. Okay. All right. But I'm impressed. So you got this nicely done. Hey guys, make sure you actually do your final stuff on computer, please. Yes, graphs, that kind of stuff, please. And you definitely should do that also on computer. And remember, you can go to fritzing.net. Does it? Hey, the Fritz ladies, is it fritzing.org or net? I can't remember.
We use the
Oh, I have it already downloaded, which is the University of Copenhagen. They actually have it so that you can draw the schematics. Piece of cake. Come see me tomorrow. We'll do it. What we got?
Got a preamp?
Oh, you finished it?
Yeah, it actually works.
Nice.
My two schematics.
Yep. Oh, you're gonna have to actually put this on fritzing, yeah?
Yeah.
Okay. All right. So we got
I
two
have it all-
piezios, right?
Yeah. I have it all taped on right now, just to see how it works out.
Yeah. My problem is with the piezios is that normally they go here,
Yeah.
or they're underneath the bridge.
Right.
So sound. I want to make mine semi-permanent, meaning
Right.
I want to be able to take it off. And they have the ones that you can stick on with, like, I just don't like to put this tape on my guitar.
Yeah.
But if you can come up with like I've seen clips where they just slide on that way. So if you guys come up with something, that'd be really cool, innovative way to actually do it without damaging or
Right.
making it permanent.
Right.
So you used a transistor, single transistor,
Single transistor.
some non-polarized capacitors, right?
Yep.
Some good resistors. All right. Does it sound good?
Yeah, it sounds pretty.
Where's my amp?
Back over
Why
there.
don't you? I'm gonna go to the next question. Why don't you get the amp? Yeah. Yep. And plug it in and jam a little bit. How about you
Bring
guys?
it over here.
Or there, I don't care.
I'll bring it there.
Huh?
We were shorting yesterday.
Yeah, we just have a ground home.
I'm thinking there's a use this right here, because I was testing that today. Just not gonna do it.
Multimeter. Go ahead, yeah. Today's a testing day. Oh, don't freak out. So basically, you got a short somewhere in the mag wire.
Yes.
That is basically, keeping you from actually doing the pickup.
Yes.
Probably. Okay.
Guaranteed it's that. I mean, it was working the day I sent it back with him.
Yeah.
And then the very next day he texted me. He's like, oh, it's shorting. And I wonder why that is.
The there's a reason why these pickups are always like in haste, so that people don't pull on them. And another thing, same thing here. When you actually go to the next gauge wire, you put it in and then you hot glue it, so that when you start tugging on it, or you give it to somebody to work with, that they don't like snap the mag wire, which is so easy to do. We'll work on it this afternoon. With my banjo. Holy crap. No, I saw this and I was like really impressed with it. And I love the wood. Yeah. It is, isn't it?
We were trying to use like different.
Is this a lefty? Very cool. I want to play it.
Yeah, these I just have to work on tuning and getting them down.
Yeah.
When I get them in the direct spots, I can just get like a sealant on it, so I can just keep it down. Because like this one always comes out. I can just do another one.
Okay.
Doesn't really matter.
And
Figure out the pickups.
yeah, pickups look pretty good, man. Maybe you can help these guys out with their pickup. Because it just, how many windings you think? A lot. Not 2,000 though. No. 2,000 is the norm. But you know what? I've done it with 100 windings. It sounds just as good. But you guys being musicians would probably be able to hear it better than I would, the difference. But to me, 2,000 and 100 basically sound the same. So have you tested these yet?
No, I haven't.
Okay, so again, like they did, you're gonna burn off the ends and then slap it underneath the diddly bow, right? And test them. So that looks good. My only concern, your project, is that it weighs a ton.
I can just.
Do you even know how much this weighs?
I know.
You do?
I can put a strap on it.
What is?
It's like 30 something pounds.
No way.
It is. It's hot. It's heavy. When I picked it up, I was like, oh, it's beautiful. I picked it up. I was like, oh my god.
Yeah. This was a waterlogged.
Did you fill it with lead?
No, it's
Okay. Where are you gonna put the pickups? Underneath?
yeah, this is all open. Just go straight through.
Okay. We might, well, let's identify where the weight's coming from and see if we can substitute other materials. Yeah?
Yeah, I can get in there. There's a big, there's a few pieces of big wood in there. It's probably wood.
That's probably the way it's coming from. We can always substitute pieces. If you're worried about structure because of all this tension, we can always substitute steel rod underneath. That would be a hell of a lot lighter than the 3. Okay. I'm happy with it. Yeah, I think you're this close. Let's just finish it off. Good job. Where the... Oh. My girl right here. Let's see. This is cool. Okay, so explain to me what you got here. Let me see that.
Musical pencil.
With a timing chip, right?
Yeah.
And a transistor, polarized capacitor.
And the speaker. Piezo speaker.
Is that a PNP transistor? Or an NPN?
It's PNP.
Okay, explain to me how it works.
So essentially, the circuit's like broken right now when you're not touching it, so the electricity's not flowing through.
Speak up a little louder.
So when the circuit's broken, it doesn't make any noise since none of the electricity is going to the speaker.
Yeah.
But when you complete the circuit, it makes noise. And so if you have something conductive, like graphite, for example,
Which is what the pencil's made of.
yeah, so
Yeah.
you can kind of complete the circuit through pencils. And like the more graphite, the more resistance, so it changes the.
Well, any conductive thing, right? Like
Oh yeah, you can also use water
Oh, I gotta see
as
that.
long as it's not distilled water. So.
Right, because distilled water doesn't have the minerals in it
Yeah,
to actually
so-
conduct, right?
yeah.
Look, let's go show that. That's pretty cool. I want to see the water. So you're gonna make music with what? Make sound, right?
Yeah.
Make sound with water. So if the higher you are on the water, that's pretty cool. So is this the final version? Or are you going to work on the design now and kind of hide the electronics? We can 3D print out, a box for it.
Yeah, I mean, I want to use a different pencil because this graphite's not soft enough. So like I actually have to use another pencil to get it dark enough.
Because you're in drafting, drawing class, right?
Yeah. So, and I want a different setup for like this. I like want to use Velcro instead, so I can pull it off easily.
I would definitely 3D print a box and then make it easy lid so that we can take it off and still show the electronics inside.
Yeah.
Yeah? Hide it for when we're using it, but then for the arts festival, have this set up so that you can draw, and if a young kid wants to play with it, they don't break your electronics. Yeah?
You know, it's just not cool.
No, I think it's very cool. Good job. You're going on to engineering?
Yeah, computer.
All right, let's take a look. How are you doing?
Doing good.
You got it done?
I got it done.
Oh, you got the liquid too?
I got the liquid going.
Get out of here.
It was a graphics wrapper problem.
Okay, this is a project that's a National Science Foundation award winner for the University of California, Davis, right?
Yes.
So, explain this to me.
So I used their program, and I was able to work on the depth perception, and I was able to take their program, edit all the data, edit all the values, so that it would work with our own sandbox.
So this is an interactive 3D camera projecting down
A 2D image.
on the sand, and if I move the sand, the topographical map changes.
Yes. And right now I have it when your hand is over, it will create water.
Really?
Yeah. But it will lag a little bit because my graphics card isn't that powerful, sadly.
Oh, so we definitely have to use the Alienware software.
Yeah, we're gonna have to use the other one with that.
And so this liquid, based upon the topography,
Yeah.
should let it rain. It's picking up my arm.
Yeah, it is. It's creating more rain, but as you can see, it's creating lag as you do it.
Yeah. And you can create a pond.
Yep.
That is pretty cool, man.
Thank you. Took a while to get everything working.
So we need to what? We need to get a better laptop,
Yep.
finalize this one, and then get the secondary one up and running
It will be done.
for the art festival. This is gonna be really cool. I think the young kids are gonna really enjoy it.
Oh, they will.
And I know ROTC is just dying to get their hands on this.
Oh, yeah.
Because to teach map reading, this is perfect for it. Yeah, brilliant.
Thank you.
We're gonna have to adjust your grade based on the rubric.
Mm-hmm.
So, do we got the white yet? Oh, there we go.
Yep.
When it gets high enough.
I found out that it was mostly just a graphics driver issue because the Linux wasn't compatible with my own old drivers.
Oh, that's cool. Create a saddle. Very neat. I'm impressed.
Thank you.
So we have to make an adjustment with your grade because of this being mostly a programmable aspect, yes?
Yes.
But I don't care, 'cause it's cool. All right, good job.
Thank you.
All right, ladies,
Alright.
enlighten me.
So what we made here is an interactive game where inside most of these cups there's touch sensors that when you throw a ping pong ball into the cup, it will set off sound, light, and make this flag spin around. But the guy that was helping us, we figured it out before vacation, and then when we came back, it just kind of malfunctioned, and we're still kind of working out the kinks. But over here, we used fritzing, and we created like a schematic of all the.
So what you're saying is that when this goes in there,
Yep.
I noticed the other day when you guys were doing just air pressure, it was setting it off.
Yeah, it's really
All right.
sensitive.
So we need to decrease the sensitivity of the variable resistance.
Yeah,
and
we
the
kind of
the pressure resistance.
Yeah, we have to figure out what is sensitive enough that it'll make
Okay.
the ping pong ball go off because the ping pong ball is very light.
Maybe
Yeah.
we can use something other than a ping pong ball too. We don't really know. We'll try to have to like figure
Now,
it out.
you should probably also use the other pressure sensors I have in there to finish off as we have time.
Okay.
Finish off the triangle with me on that. But this is prototype, so we're in the process of figuring that. But the motor spins
Yep.
when it
Yeah,
goes
we
in.
just have to.
We used a lithium battery at first,
Yeah,
but
probably
these aren't
wouldn't recommend
reliable. Yeah.
that.
So we
They're
had
a
it
little
set
more
up.
dangerous. Give me that. Okay. I do have the regular batteries in the back that we can
Yeah,
actually
we were
set.
trying to do it without any battery.
Oh, you're gonna try to tap
We're
off
gonna-
the
yeah.
power source from the laptop? Okay, that's interesting.
I got the fritzing.
Oh.
There we go.
Oh.
See, the motor will spin like that, and what it is
Because the ball's on
Ball's
there.
in there already?
it's just because it's powered. With the sister board, it's like a switch, so that when we hit a sensor, the sensor will turn on the sister board, which is what the lights and the motor are connected to. And over here,
Then the lights are
I take it this is your first time actually using
yeah,
a processor?
yeah,
So it's a big learning curve here, right?
yeah.
Alright.
And
And there's your-
this is like our program
Your
that
C code, yeah?
that has like the sister board. It has all the sensors, like the sensitivity. It's, like this is basically where we adjust everything, like how bright the lights are gonna be.
I would actually put in some serial monitors so you can see your serial monitor is 0. Oh, no, you do have some input. Okay, cool. So if I just take out the auto scroll, you can actually see your numbers. Okay, cool. So that we can actually look at that and tweak your sensitivity based
Yeah.
on that. All right?
Yeah.
Yeah. Don't mess with my lithium batteries. Okay. You gotta actually have to take a packet that I give lithium batteries out. It's about like 30 pages because they do have a tendency to blow up. So just don't touch them. But hey, it's not dangerous. It's not fun, right? So I'm happy with you. So what are you gonna do next? Work on.
Add more sensors and try and figure out a new way to connect the battery to as like a power source. We're thinking of just using an outlet, because either way we have to be connected to the computer, because we need to have the programming attached to the breadboard. So we just need Mike to program that in.
So Mike Abel, who's a junior, right?
Yeah.
He's helping you guys with this because he has much more programming skills.
Yeah. He kind of helped us map together the program.
But he's not in your class, right?
Yeah.
All right, cool. All right, yeah, looks good. As long as you're learning something along the way, and we can have these lights up and running.
Yeah,
too?
these lights. The lights are connected to this. We just have to figure out how to do it without the battery.
Right. Yeah. Fine. I'm happy. How much time we got left in class, guys?
10 minutes.
10 minutes. All right. Well, let's go take a look at preamp. So here, basically, this is what you've done.
Yes.
The electronics that were inside my old guitar, we ripped them out, and you had basically made the same thing.
Yep.
Now this isn't someone else's project. What they did was they took a piezo and put it on the inputs, so that now we can make a throat mic.
Right.
And might be an interesting thing if you want to take it over, because that kid hasn't been back for a while. I think he's out sick. But it'd be cool for the arts festival if you actually could make a throat mic based upon this, and then you could do a little tune with that pit preamp and this throat mic. All right, let me hear it. Nice, very nice. So what we should do is actually think about 3D printing in SolidWorks a little case for it.
Yeah.
Or go to Radio Shack and see what they have, right? But definitely the 9-volt battery hanging on.
yeah.
Right? So we got it up and running. That's the first step. Now we just got to make it look pretty and professional.
Yep.
I'm very impressed. Good job. All right, so we can jam later. I got 10 more minutes, so you guys can work on your projects. Oh, what? Oh, you want to do that one? Is it ready to go? Yeah. All right, go. Okay, come on. So sometimes we have students that come from other classes. If you look around my room, it's very eclectic. Everything in here is student-made. TV was donated. We made the brackets for it. The boat's over in the corner. Everything in here is student-made with very little budget. And kids from other classes will come in. They have open door policy, and they can come work on their projects at any time. So here's an example of a student working on an atmospheric gun, or we call it an atmospheric ballistic. Ready when you are. So this is going to be a little loud, guys, okay? So we'll give you a countdown. So inside here we have a ping pong ball, and we're using the vacuum pump to take the air out, basically creating outer space inside there. You haven't seen this yet, have you?
No.
So, you got your knife? 101.3 kilopascals is the atmospheric pressure at sea level, which we are at. Doesn't seem like much, because a Pascal is a dollar bill sitting on a desk, right? So that's 101.3 dollar bills sitting on a desk. But what you'll see here is it can be quite destructive. Inside here's a ping pong ball. He is going to now allow 101.3 kPAs through, and he's going to hit this ratchet. Okay?
5, 4, 3, 2, 1.
And what you can see here, though, that ratchet moved. And when a ratchet moved, we can actually high speed it, calculate the altitude that it actually, the height it changed, and figure out the gravitational potential energy. You with me on that? We can get the GPE. We can then go back. Is it going to be equal to the KE, right?
Here's a ping pong ball.
And then we can calculate the velocity of the ball based upon the mass of the ping pong ball, which is now obliterated. How many ping pong balls have you gone through?
We have 2 left out of like 38.
So this is what we do. We like to play and hopefully learn something along the way. Yes? Sure. Okay. Good job. You going to have that ready for the arts festival too?
It's ready for anything.
Well, we need to work on a mounting system. You know, tripod would probably be the best thing to do.
All right.
All right. And there's some hurricane strapping over there. Probably want to make a bracket out of it, or
We can
take
just
some
tie it to a sawhorse if we want to.
I'm with you. So that would be. Oh, you got it ready? You tested it yet? Hey, want to go? Somebody grab my amplifier, small one, and bring it back here. So we should be able to. Did you lit the ends, right? Okay. And I need a one cable. So grab a cable. And we can test. Take these, put it on the 2 ends. Yeah. Where's my amp?
I took it.
Bring it over here. Yeah, give me that. Plug it in. Here. So go ahead and plug that in. Okay. Everything up. Good boy. All right, brother. So, obviously, one of these is positive, one's negative, right? So, put that there. And I'm just going to hold it. You got it on? Yeah. Okay. There's a little space there. Huh? They can hear it, right?
Kind of faint, but yeah, I can hear it.
Now, what the problem is right now, there's only 2 ways you can get more output out of that. Better magnet. No, not going to happen, right? Or more mag wire loopage. Yeah? And there's a third way. Preamp. Because right now you're getting this much signal. Yeah? This much signal going to my amplifier, which is now taking this signal to here. But if we actually put a preamp, we take a little signal here, put it in the preamp, and then it goes to the amplifier and we get it. Boom. You with me on that? But nice. So let's test the other one. Did you burn the ends off this yet?
Yeah.
Just pull this. Go ahead, try that. Make sure you have a good connection. Is that amp on? Hold that right there. Okay. I'm gonna snap. I can hear it. I think we need to tweak that a little bit more. Okay, so I think we might want to look into doing a small preamp. It shouldn't be that difficult. I got all the parts. Yeah. And we'll crank the crap out of that, all right? Yeah. All right. So, ladies and gentlemen, thank you for your attention and everything else. Tomorrow we'll be back to normal. Be loud and obnoxious in here. And just be prepared to actually build some stuff. I'll be here this afternoon if you need help, and I'll be here after school if you guys need any help with your projects. Yes? We only got 3 more weeks before the Arts Festival. And there's the bell, ladies and gentlemen.